Functions is our focus for today. Grab your note packet and open to the functions lesson. If you don't have a note packet, you know that you're taking your notes in your learning log. Get the title and the learning target. I can define function and use function notation to write functions written in your learning log there. Remember, this is a video, so you can pause at any time to write down what you need and rewind if you've missed something. All right, what is a function? A function is a relation in which every member of the domain has one range. So we talked about identifying functions, and there's the definition again. Remember, this idea you've actually worked with before, in that when you started doing math a little bit younger, maybe this was elementary school, you were given an input, and you would put that input into like a little machine, and then you'd get an output. Well, the input will now go into the function, so the machine has changed into this equation that's a function, and you will get the output. So that early work you were doing with those little input-output machines was actually leading up to this moment here, okay? So you put an input in, and then you get an output out. Function notation. What is function notation? We have an example here. F of x equals 12x. So typically you'll see function notation written with that f of x, but you're also going to see it with other letters. There can be g of x, h of x, because we can have functions within functions. But for right now, you'll see it as f of x. And this is very similar to our unit before when we were working with slope-intercept form. Okay, y equals 12x, same thing. X was your input, y was then your output. Okay, so very similar, but function notation is this idea here of f of x, and that's how you say that, f of x. Okay, so let's see how this works. How do I find the value of a function or the output of a function? You will substitute in for what they tell you the input is, and then you will solve to get that output. So this is how questions will be stated. Find f of 11, that's our input, if f of x is 1/2 times x plus 5. So right here, again, this should look like slope-intercept form. I mean, you should still be kind of in that mode, thinking, okay, my slope is 1/2, my y-intercept is 5. We've just changed the y to this function notation, this f of x. So how we solve is we write the 11 where the x is on both sides of the equation. So f of 11 equals 1/2 times 11 plus 5. And then we're going to do the math on the right. So 1/2 times 11, if we do that math, we know that's 11/2 plus 5. 11/2 plus 5. Well, let's change that 11/2 to the mixed number. So that would be 5.5 plus 5. And 5.5 plus 5 is 10.5. So when your input is 11, your output is 10.5. And you might want to make those marks on here. This is your input, and this is your output. Okay, let's look at another example. How do I represent functions in a table? Okay, so a function table is going to look a little bit different than the tables we've been working with. On the left, you will have a column for your input. Then you'll have the function in the middle, and then your output. All right, so once you've got that set up with the titles, x your function and your output f of x. You're going to set up the table, and we're going to use 5 standard input values. So -2, -1, 0, 1, and whoop, I don't have enough rows here, do I? 2. So these 5 values, they give you perspective on both parts of the number line, 2 negative, 2 positive, and then your origin. And we're going to substitute those in and then solve for f of x. So when the input is -2, I'm going to do 7 plus 3 times -2. And I can do that math over here. 7 plus 3 times -2 is 7 plus -6, which is 1. Then I'm going to do 7 plus 3 times -1. 7 plus 3 times -1. 3 times -1 is -3. Plus 7 is 4. That's a battle. When my input is 0, 7 plus 3 times 0. Anything times 0 is 0, so that leaves me with 7. Now I'm getting into my positive inputs. So I expect to see that output to get higher. 3 times 1 is 3, plus 7 is 10. And when the input is 2, 3 times 2 is 6, plus 7 is 13. Now what you've essentially got for yourself is 5 ordered pairs. Input, output. Input, output. Input, output. That's also our y-intercept. Input, output, input, output. So that's how you would use a table to represent your function and then get those ordered pairs from that table. How do I represent a function from a real world situation? Okay, this situation is a little bit older, but you'll get the idea of it anyway. In a not so recent 82 game season, Dwight Howard of the Orlando Magic averaged 20 and 7/10 points per game. His approximate total points scored, which we're going to call P for G, P of G, is a function of the number of games played. So G represents the games played and P represents the points. Define the independent and dependent variables. Okay, so we kind of already did that there, but I said it verbally, but now we'll write it out. So your independent variable is your number of games, or your G. And then your dependent variable is the P, the points per game. So we want to write the function of points scored per game in terms of P of G. So P of G equals 20.7 G. Now, where did that 20.7 come from? It averaged 20.7 points per game. So each game he'd get an average of 20.7 points. So we use that 20.7 and multiply it by the number of games. How many points would he score in 18 games? To figure that out, you're going to substitute 18 for your input into the function you just wrote. Do that multiplication, 20 and 7/10 times 18, and you will get P of 18 is equal to 372.6 points. So over 18 games, Dwight Howard of the Orlando Magic scored 372 and 6/10 points. So about 373 points. All right, functions. Bring these notes and let's practice.